All right, good morning everyone from High Point Baptist Academy Physical Science. This is the video instructions for how to make a free fall poster. I'm just going to turn, it's going to be more like a graph. That's not completely filled in. It's going to look like that, but before we start on the poster, okay, we're going to talk about free fall. What is free fall? Free fall is when an object falls and there's no air resistance, okay, and it just keeps falling and falling, and what happens? Well, the velocity increases. With every second, that object is moving faster and gaining more distance with every second. If an object goes at a constant acceleration, like in free fall, we have some nifty formulas, okay? Let's take a look at them. So velocity equals 9.8, remember that number, meters per second squared. I'm not going to write that down. We could write that down and show how the units cancel out, but I don't want to do that right now. I just want to show you how to calculate the numbers. So velocity equals 9.8 meters per second. How fast would an object be going, any object in free fall, after 1 second? So let's just say after 1 second, all right, it would be velocity equals 9.8 times 1 second. It would be going 9.8 meters per second, all right? So there you have 9.8 meters per second. We multiply by meters per second squared. We got 9.8 meters per second. So as soon as you let the object go, it's starting at 0, right? But immediately after 1 second, it's already going almost 10 meters per second. So let's see if we can figure out what the average velocity is in that first second. Well, how would you figure out an average? Well, you would take both velocities, its first velocity and its second velocity. So the first velocity was 0 and the second velocity was 9.8. You add them together and divide by 2, right? Two velocities, the first and the last. Divide by 2 gives us 4.9 meters per second. So the average velocity in the first second was 4.9 meters. The question is, how far did it fall? Well, if the average was 4.9 meters per second, right, distance equals velocity times the time, and the time interval was 1 second, 4.9 meters per second times 1 second gives us 4.9 meters. So after 1 second, the object will have fallen 4.9 meters. What about after 2 seconds? Well, the velocity after 2 seconds is going to be same formula, 9.8 times the change in time. I'll just write meters per second squared because it's good to do that. Times 2 seconds, seconds cancels out. We have 19.6 meters per second. So after 2 seconds, at the end of 2 seconds, this will be its final or total velocity, okay, but it's going to keep gaining speed, but we're just focusing on stopping it at 2 seconds. It would be 19.6 meters per second. What would its average speed be between the first and second second? So I'm going to put average velocity between first and second. All right, a little bit of a tongue twister there. So the first second, the end of this final velocity was 9.8 meters per second, right? And then at the end of 2 seconds, it had gained all the way up to 19.6 meters per second. We're going to average those, okay? And I believe when you average them, it should be 14.7. I'm going to do it real quick. 19.6 plus 9.8 divided by 2 gives me 14.7 meters per second. All right, that's the average velocity between seconds 1 and 2. How far does it go between seconds 1 and 2? Distance. I'm going to call that the new distance, all right? Because the object already fell 4.9 meters. How far does it go in the new distance? Well, the new distance is the distance equals the average velocity times the time, right? So we're going to do 14.7 meters per second. And the length of time between the first and second is really just 1 second. All right, does that make sense? From second 1 to second number 2, okay, that's a time span, a time interval of just 1 second. So it will have fallen 14.7 meters. Okay, so first it falls 4.9 meters. Then it falls an additional 14.7 meters, right? So we could say, we could put a line there. Hopefully you can see it. I'll tip the camera down in a minute. Total distance after 2 seconds. Okay, well, we're going to add them together. We're going to say 4.9 meters after 1 second plus 14.7, 3 times that first distance, right? All right, so we're going to add those together, and we're going to get 19.6 meters. All right, so that's all the math. You do not have to do that, but let's take a look at what you're going to do for your poster. All right, so I'm going to tip this down so you can see the total distance after 2 seconds. We added the distance after 1 second to the distance after 2 seconds and got 19.6 meters. Now, let's turn my video here over to what you need to put on your poster. All right, your poster, let's see here if I can do this without dropping the camera. All right, your poster is going to be 2 lines, all right? And for those 2 lines, you need to choose 2 different colors, all right? One color will be for velocity, and the other color will be for distance, all right? So you may want to pause the video, okay, and you're going to need at least 2 plain pieces of paper, if not 3. I actually haven't measured this out. I think you need at least 2, and tape them together. You will need some extra paper there. All right, one sheet, 1 8.5 by 11 won't be enough. You'll have to connect them. All right, and then you'll need a ruler that measures in centimeters, and you're going to draw a line in one color to represent the velocity. A straight line with your ruler down both pieces of paper, okay, to represent the distance. All right, so you can pause the video and draw those lines and connect your paper, then turn it back on. All right, now if you're back, put down the formulas. Velocity equals 9.8 times the delta t, the time interval. Make sure that your formula for velocity matches the color of your line for velocity. This is really important. So you want to color match, all right? Whatever color you used for your line, which is hopefully to the right side of your paper because you need to write all this down, your blue line, or whatever color you choose, needs to match your distance. Distance equals the average velocity times the change in time, all right? Then you're going to put underneath that your key, because you're going to make 1 centimeter equal 1 meter per second, okay? And that's the velocity, so that's going to be the color of your velocity line. And also 1 centimeter is going to equal 1 meter, and that will be matching your color for your distance, all right? underneath that, you're going to put a table. I'm going to grab, I don't want to move my iPad, it's probably going to fall over, but you're going to make a table, and I'll zoom in on the table at the end, showing the time intervals in seconds, the velocity, the new distance, and the total distance. So let's do this last. Let's take a look at what you need to do with your velocity line. All right, so you drew all this, save some room for a table. Where do you draw these dashes? Well, we determined that after 1 second, the velocity would be 9.8 meters per second. Let's just see where my camera is. Can you see that? I'm going to go to where you can see both the math and the two lines. There we go. All right, so you're going to take your ruler. All right, I use decimeters so you could see it a little bit better. But here I have it on 9.8. So you're going to use 9.8. If you have lots of posters and you want to use decimeters, you can, but just use a centimeter. So your line, your first line is going to be very small, all right? The velocity is going to be very close together, all right? Then the second one will be at 19.6. So it's going to be around, the first one's going to be around 10 centimeters, right? And the second one's going to be around 19.6 centimeters, all right? You're going to put that in there. Actually, I did use centimeters. I'm sorry. All right. Then the third one, I'll give you the numbers for these in a minute. The third velocity, if you were to calculate it, if you were to take 9.8 times 3, the third one's going to be at 29.4. All right, so you make the next one at 29.4 centimeters, and then the last one is going to be at 39.2 centimeters. All right, so you can write those in, and we're going to go ahead and write in the velocity at that second. So second number 1 equals 9.8 meters per second. Second number 2 equals 19.6 meters per second. All right, and I'll give you the values for 3 and 4. So we've got 29.4 meters per second and 39.2 meters per second. All right, so that's the velocity at the end of each of those seconds. All right, so you may need to pause, okay, right? Because if you write down 1 second equals 9.8 meters per second, so you want to pause and measure that, all right, so that everything ends up coming on the right mark. All right, once you're done with your velocity, okay, then you want to turn back on the video. We're going to do distance. Distance is a little bit more tricky. All right, so for distance, okay, again, you're going to take your first line is going to be 4.9 centimeters down to represent, okay, 4.9 meters in real life, okay. That's how far it fell in the first second. Now, when you finish that, turn the video back on, it falls an additional it falls a total of 19.6 meters at 2 seconds. How far is that in addition? Well, we calculated that to be 14.7 meters. So you're going to take a dotted line and put 14.7 meters in between, right? 19.6 is how far it fell. So let's take a look at finding some of the rest of the numbers. All right, let's go over here to the math. What if we did after 3 seconds? All right, again, I don't need to see the math on the poster. I just am showing it to you. So I'm going to erase some of this. All right. After 3 seconds, well, 9.8 times 3, the new velocity is going to be 29.4. All right, and that is going to go on your velocity line 29.4 centimeters down. What's the average? Well, we're going to take 29.4 meters per second plus 19.6. All right, and that's going to give us the average speed in between 2 and 3 seconds. So let's add those together. 29.4 plus 19.6 divided by 2 is going to give us 24.5 meters per second. All right. Now, how far will it fall in between the second and third second? Okay, in between these 2 seconds here, how far will it go? Well, velocity times time, 24.5 meters per second, times 1 second, 24.5 meters, because we're only talking about the time between second number 2 and second number 3, so it's only 1 second. All right, it falls an additional 24.5 meters. So over here in the dotted line between these 2 lines, this should represent 24.5 meters. It's a little thick, 24.5 meters. Right? Now if I add 24.5 meters to 19.6, I'm going to say after 3 seconds, I'll just add it over here, plus 19.6 meters. I'm going to get 44.1 meters, right? So I'm going to write that here. The distance from the beginning to the next line should be 44 centimeters, because that represents in real life 44 meters. And that will be at 3 seconds. So again, it gained 24.5 meters. Your object gained 24.5 meters in between the second and third second. So it came down to 44.1 meters. And what you want to do is measure all these in centimeters so it fits on your paper. All right. The last one, I'm going to give you the answer. The last one's going to fall to 78.4 meters at 4 seconds. Let's see if you can see that on the video. 78.4. All right. How many additional meters did it fall? Well, let's give you that answer there. It fell 34.4 meters. All right. All right, so if you have any questions, please see me during Zoom tomorrow. We'll do this again. All right. So on your poster, you do not need to have any of the math, but you do need 2 different colored lines. Okay, one for velocity, 1 second, marking the separation by centimeters. 1 second equals 9.8, so that's going to be 9.8 centimeters from the top. 2 seconds equals 19.6 meters per second. So this little dash will be 19.6 centimeters from the top. The next one will be 29.4 centimeters from the top to represent the velocity, 29.4 meters per second. The last one at 4 seconds will be 39.2 meters per second. On your poster, Okay, you'll also have the distances written down. Okay, on the right you put your total distance, how far it falls. Altogether, at 1 second it fell 4.9. At 2 seconds it will have fallen a total of 19.6. At 3 seconds a total of 44.1 meters. At 4 seconds a total of 78.4 meters. In between each dash, each of these marks, you can draw a dotted line to show the distance between these lines: 14.7, 24.5, and 34.4. Last thing you want to do to make this a valid poster is to put all your numbers in. So I'm going to write the numbers in and then I'll zoom in so you can see. At 1 second, the velocity was, okay, you're going to put not the average, you'll just put the final velocity. So you put these numbers here: 9.8 meters per second, 19.6, 29.4, and 39.2. Now I know this is a little far away. I'll zoom in a minute. The new distance, okay, that means the distance right here, the distance between the dotted lines. After 1 second, it's 4.9 meters. 2, you add 14.7 meters. After 3 seconds, you add 24.5 meters. And after 4 seconds, you add 34.4 meters. Now the total, you're going to be adding two numbers together, except there's nothing in front of the 4.9, so it's 4.9 meters. Okay, that's the total. Here's the second number. It's 14.7 plus 4.9. That gives us 19.6 meters. The next number, 44.1, is 24.5 plus 19.6. The last one, 78.4, comes from 44.1 plus 34.4. All right, that will be everything you need for your poster. Okay, so you can do your poster and take a picture of it and send it to me. All right, I'm going to go ahead and zoom in on this so you can pause the video. All right, see, we have a heading for time interval, a heading for velocity, a heading for the new distance, and a heading for the total distance. All right, so when you make your poster, please be as neat as you possibly can. Now, if you are interested in a little bit of enrichment or a little bit of extra math, just stick with me and I will show you another formula. All right, I'm going to erase this. All right, little shortcut. What if you want to find the total distance and you don't want to find the average speed? You want to just skip to that answer. Well, you can say distance is equal to 1/2 times gravity, which is our 9.8, times the time squared. So we're going to say distance is equal to, if I take 9.8 and I divide it by 2, I get 4.9. So I'm just going to use that number, 4.9, times the time squared. So I can say distance equals 4.9 times 1 second squared. That would be the first second. So let's just write them all out. Equals 4.9. Let's do 2 seconds squared. Distance equals 4.9 times 3 seconds squared. And distance equals 4.9 times 4 seconds squared. All right, and so you can take your calculator and see if you get the same total distance. 1 squared is 1. We're going to get 4.9 meters. Here we're going to get 4 times 4.9. We're going to get 19.6 meters. And then if we did 4.9 times 3 squared, we would get 44.1. And if we did the last one, 4 seconds, 4.9 times 16, we would get 78.4 meters. So a nice shortcut, a nice great formula to use to get the total distance without needing to determine the average velocity in between and then adding everything up. All right, you go straight to the total distance. Pretty cool, right? So again, this is free fall. This is if an object has no air resistance and it's falling at a constant velocity. It's not changing. It's falling at this constant g, 9.8 meters per second squared. So then we can use this nice, neat formula to determine what our speed will be if we could fall without air resistance, right? Our speed or our distance that we would cover would be 78.4 meters. Okay, so hope you enjoyed learning about free fall, and if you have any questions, please Zoom me.